Okay, so that brings us to 7.5 box packing. So in this case, we need to write a function that's given the dimension of a box and an object we want to put into the box. And no, wait a second. It's the dimension of the object and the dimension of a box. And if the object does not fit into the box, we should compute how much of the object is sticking out of the box and return that as a tuple. So in this case, our object has dimensions height of 2 and width of 5, and the box has a height of 4 and a width of 2.1. So that means that in the first dimension, the object fits inside the box, so it has like no like element, like it doesn't stick out in the height. So that's why the amount that sticks out should be set equal to 0. But in the width, the object is too wide, so we compute how much is sticking out. In this case, it will be 2.9. Length in whatever units this happens to be in, and therefore we should return 0.2.9 in this case. Okay, so let's do that. So that function is called box packing. So let me copy paste this example and go to my IDE. And we got box packing here. So I just call it with this example. Let's just do a print statement. Let's call the value we want to return for XS, and then we'll insert a breakpoint here, and then we'll think about how we define this variable in the debugger. So I'm just going to enter the debugger, and now we can see that if I go to the debug console, I can see that my object has this dimension and the box has this dimension. Wait, so let's do object height, comma object width. We can get those from the object's dimension using this syntax. And that will be a convenient way of unpacking this tuple and get the height and width in one line. And then I can get the box height and the box width, and we can get those using the same notation. If you're not comfortable with this tuple unpacking stuff, you could of course also have done box height is equal to box index of 0 and box width is box index of 1. This would of course be completely equivalent, but this is a little more compressed. So the reason why I'm doing this is because when I compute the excess, I'm kind of doing the same thing for the height and the width independently. So if I can just figure out how to compute the appropriate number for one of the coordinates, I can just kind of repeat the same thing for the other coordinate. So let's do that with an if-else statement. So if object height is less than box height, let's do less than or equal, although it won't matter then we say that the difference in height is 0. There's nothing that sticks out. Let's call it stick out height. Else stick out height should be equal to how much excess we have, and that would be equal to the box height, object height minus the box height, I guess. And then I do the same for stick out width, and then I can define the excess. I guess hopefully it's spelled correctly, and that could be stick out height and stick out width, like this. For the stick out width, I do exactly the same. And now it's just a little bit search replace. Now, some are going to look at this code and say, well, what if the object and the box had many more dimensions potentially? That would maybe not make geometrically that much sense. There is a way of generalizing this code using a small for loop, but this is completely fine with me. I don't mind a little bit of repeated code if I feel it clarifies what the problem does. Let me just try to run all of this code and see if it's correct. It's much faster to do that in the debugger than it is to restart the program. So I'll just Shift Alt E to run it, and then I'll explore if this access looks correct, and it does. So no access there. I remove the breakpoint. Sorry, I stop the debugger using the stop button, and now I can run this file, and it does the correct thing. So we go to the testing, and we I don't know which one is it. Box packing, I guess. It works. So that's how we can solve this problem.